Hello, today we're going to talk about finding the centroid or the center of mass of a shape via the method of composite parts. So the method of composite parts serves as an alternative to finding centroids or the center of mass via integration. So the basic process we'd go through in all of this, first we would take our shape and break it down into kind of smaller and simpler shapes and volumes. Next, we're going to look up in a table the kind of area, volume, or mass for each of those shapes, as well as the centroid location. So in the Adaptive Map textbook, as well as in a bunch of other sources, we've got kind of these general tables that are generated via integration, and they show you the centroid locations for kind of simple shapes or simple volumes. Alright, so after we get the kind of area, volume, or mass, as well as the centroid locations, those coordinates, I'm going to combine the results in a certain way to find the overall centroid location. We'll talk about that in a second. Alright, so step one, to use this method, we first need to break our shape down into simple parts. So here is a part, it's kind of like a semicircle and a square, and I've got kind of a like triangular cutout over here. You can imagine this would be quite difficult to find via integration. So we are going to break this down. Each of those simple parts must be in that centroid table. This is kind of the key step in this. So in my centroid table, I do have a semicircle, I do have squares and rectangles, and I do have triangles. So the regular areas are going to count as positive areas, and any cutout or hole is going to count as a negative area in this. So shape one, I'm going to do this semicircle over here. Shape two, I would do kind of this whole square right here. And then actually shape three is going to be my cutout, and so I take a triangular chunk off of that corner there. And so now I've got three shapes: semicircle, kind of square, and I've got the kind of triangular cutout down there. I'm going to throw these into a table. So for the 2D centroid location, I want to look up the area and the x and the y coordinates of those centroids for each of these individual shapes. Alright, so we want to record these all kind of in a table to keep track of them. And we need to remember to take orientation and position of each shape into account when we find the centroid of each shape. So this is, we want to make sure that all of the centroid locations are with respect to a single origin point. So even if it's kind of in a different orientation in our table, we'll need to kind of adjust that to make it work for us. So I've kind of set my origin point over here. It's kind of on the tip of the semicircle. And this is what I have in my centroid table in the Adaptive Map textbook. So you'll notice one thing, kind of the semicircle in my table, I need to flip it up this way for this piece here. And also I'm measuring from the other side. So the centroid location in here, it's listed as 4 over 3 pi times r, and that's the distance from kind of the base of the circle to the centroid. But I'm going from the top of the circle down to the centroid for my x coordinate here. So I'd actually need to adjust this. I need to go, well, this total distance is the radius r, and I do r minus this value here to find my x coordinate. Again, the whole thing is also tilted up. The y coordinate, it looks like I'm kind of right in the center of the semicircle here, and the centroid's right in the center here, so I don't need to do anything there. My y coordinate would simply be 0 for the centroid there. Another thing you're going to see a lot of is with something like the rectangle or the square over here. I also need to kind of take into account, I need to get to the shape first. And so the centroid of my rectangle is 1/2 of the base, so it's kind of right in the middle of my rectangle. So I've got, if this is 4 inches wide, it'd be 2 inches here. But I also need to take into account my x coordinate. I also need to add in the radius and then 1/2 of the base here for my x coordinate for my centroid. So all of this needs to be taken into account when I'm adding values to this table over here. All of these x and y values need to be with respect to the origin point over here. Once I have the values in the table, it's pretty simple to do the calculations. So the kind of average x coordinate is going to be, or the centroid for the overall shape is going to be area 1 times x1. So area 1 times x1 plus area 2 times x2 plus area 3 times x3. So I kind of sum all of those up. And I'm going to divide by the total area. So area 1 plus area 2 plus area 3 is the sum of areas on the bottom. Remember again, negative areas, that cutout or that hole is going to be a negative area. Alright, for the y coordinate, it's going to be area 1 times y1 plus area 2 times y2 plus area 3 times y3. That sum divided by just the sum of all of the areas on the bottom there. So if I do those two calculations, and if I have all these values in the table, I can go ahead and find my centroid coordinate fairly easy with the method of composite parts. Alright, so this is for 2D centroids. Let's talk about how to modify this for 3D centroids. We're going to use pretty much the same process. There's kind of two big differences. The first is, rather than using areas for each of those shapes, I'm going to use volumes. So I put volumes in my table here, and I've got kind of a cylinder area and a cone area right here. And also I'm going to have x, y, and z coordinates to deal with because I've jumped to 3D. So I need to find the x, y, and z coordinates of each of my centroids for the individual shapes. And I'm going to do an x, y, and a z calculation for the centroid of the overall shape. Modifying this one more time, if I go to center of mass, there's really only one change between the 3D centroid calculation and the 3D center of mass calculation. And that's going to be, I change out, I'm no longer going to deal with the volumes, but I'm going to deal with the masses. So it's going to be kind of the masses in the table here for shape 1 and shape 2, and the masses in my calculations for the centroid. So with that, that's all we have for the centroid and center of mass calculations via the method of composite parts. Thank you for watching, and I hope to see you again.